Welcome back to the next chapters, chapter number 4, moving charges and magnetism. Why we are saying moving charges here? Suppose if you are saying static charge, it will not produce magnetism. Only the moving charges are producing magnetism. So, how the current and magnetism are interrelated? Who discovered or who invented the first these scenarios? Yes, of course, Hans Christian Oersted, only the first person to give the interrelation between current and magnetism. Yes, yes. So, what is a Oersted experiment? So, when we are a current carrying in a straight wire, right? And that straight wire, we are going to brought a small compass needle very closer to that wire. When you are passing a current through that wire, the compass needle will deflect. Yes, this is a Oersted experiment, right? The deflection is due to magnetic field, right? So now we are going to deal about these chapters, and in these chapters we are going to deal about full and fully magnetism and current and magnetism, and what about the moving particles, how the magnetic field are the force exerted on the charged particles, how the particles are accelerated by using cyclotron, right? So these are all the main topics we are going to cover here, right? Okay, now move on to the first one. We have Hans Christian Oersted, right? Here I have battery and key, and the current is flows from positive terminal to negative terminal, as we know, right? So here I have a plain paper, right? And in that paper I have placed one compass needle. Yes. So listen here, the current is passing from top to down, that we are saying, into the paper. The current is passing into the paper, right? And same scenario, I am changing the polarity. The negative terminal here and positive terminal is here. So in this time, the current will flow from the downward direction to upward direction, that is out of the paper, right? Try to understand what is into the paper and out of the paper, right? So the current goes from downward to upward, that's we are saying that out of the paper, and this one is into the paper, when up to down, right? In both the cases, this compass needle get deflected. Okay, so how we can predict the direction of deflections? Do you have any idea about, as you studied in lower classes, right? Yes, we have right hand thumb rule or thumb rule we have, right? So this is my right hand. So suppose the current is passing upward direction. So these rest of the four fingers are magnetic field. This will move this direction, right? So the current will move north to south. Yes, this is north, this is south, west, east. Then it will deflect it towards east direction. So I cannot bend my finger here, right? Yes. And suppose if it is in downward direction, then it will goes to, yes, west direction. So this is a concept here we are going to apply here. So what will happen when we are going to apply into the paper? The compass needle will get deflected into the, so this is downward direction, right? This one, right? So if you are taking as downward direction means, so north, south, this is west, this is east. So the deflection will be happen in the west direction, right? Yes, I hope you clear. And suppose right, in downward direction, so north, and this is south, west, east, right? When the current will and compass needle will deflect in the east direction, right? Yes. And suppose the current goes in upward directions, right? Upward direction. This is upward direction. So that time the current will deflect towards west direction. This is in downward direction, right? Downward. So deflection towards east direction. This is upward direction. So deflection towards west direction, right? So when we are changing the direction of current, what will happen? The needle's orientation also reverse. So here the deflection happen in the east direction. Here the deflection happen in west direction. The deflection goes in the west direction, right? And here I draw for the into the paper. So into the paper, all north is aligned or oriented in this direction. Yes. So and similarly for out of the paper, look at here. This is a north pole, but here say that the orientation is reversed because of we are changing the direction of current, right? Therefore, the orientation also reverse, right? And all those are imaginary circles here we are making us, and the alignment of compass needle is a tangential to an imaginary circle. So each and every one is a tangential part. Yes, tangent means one point. So each and every compass needle in a tangential point in a imaginary circle. This is an imaginary circle only, not ours, right? And suppose if you are sprinkling some iron fillings in that papers, we are removing the compass needle. Instead of that, we are sprinkled some iron fillings. What will happen? It produces concentric circles, right? The closer concentric circles indicates strong magnetic field, and far away circles indicating weak magnetic field when compared to close circles, right? Okay. Why we want to study this topic now? Because this is the fundamental of electricity and magnetism, and later onwards we are unified into electromagnetism. In later onwards, you people are going to study the electromagnetism. Who give the first idea about electromagnetism? Yes, Maxwell. James Maxwell gives the first idea about electromagnetic waves, as light will be acted as electromagnetic waves. And apart from that, the radio waves are discovered by Hertz, and later onwards is produced by J.C. Bose and Marconi, and which develops the communication part. And apart from that, any other thing I missed? Yes, one more thing here we have. The current is large, the needle is closer to the wire, and we are ignoring the earth magnetic field here in these concepts. Yes, is it clear? So what you are going to study about the magnetic field, how we are producing while passing a current in a straight line conductor. Yes, and moreover we are going to study about the magnetic field exerts a force on moving charge particles like protons and current carrying wires, and also how produces magnetic fields, and we are going to accelerate the charge particles, and also how currents and voltages are detected by galvanometer. So these are the topics we are going to cover in this chapter. I hope you understand this basic concept. Try to understand well, because this is the basic of this unit as well as the electromagnetism. Thank you. See you in the next video. For understanding, I am going to choose a single plane of paper and assume that this pencil has a straight line conductor. So what I am going to do, I am just make a small hole and a straight line conductor, right? And we have the plane of paper here, right? We have the plane of papers here, which is perpendicular to the direction of current flow. This is the current flow, and we have the plane of paper which is perpendicular to that current flow, right? So the first case we have when the current is in downward direction. Downward direction means use the right hand thumb rule, right? Yes, right hand rule. So use right hand rule, north, south, east, west. So it will deflect it towards east direction. As in that, this one is compass needle, this green is north, and this one is south pole. So when the current is passing from top to bottom, that time how the magnetic deflection will take place towards east direction, right? It will deflect it towards east direction. Suppose if I am changing the direction of current, the current starts from bottom to top. That time the current, this compass needle will deflected in the west direction, right? So the compass needle will deflected in the west direction when bottom to top. When we are applying top to bottom, that time the compass needle will deflected in the east direction, right? So for your better understanding, I am doing a small demo of this concept. I hope you understand well.